Alrighty guys, I'm just getting myself set up here. Hopefully it won't be too long. Okay, and just a reminder of what we've done already. We have the ability to draw walls for like different rooms within the maze, or a maze. And what we've done here is created a binary maze type. And we'll go look at the code there, but it's really simple. And then all we did at the end of yesterday was have the ability to stack a few mazes on top of each other. So yeah, I've got two different mazes, randomly generated sizes. Yeah, and just like one sitting on top of the other. So one sitting closer to the user than the other. And we've got a little camera that we can kind of float around. We've got a couple of lights in the scene, which we'll need to do a bit of work on at some point. So there will be some kind of graphics work required to do anything we want. The other idea was possibly to create floors here so that you could, like, one maze won't, like you won't be able to see mazes underneath other mazes. The issue there is when you have like 30 mazes stacked on top of each other, it starts to look pretty crazy. But yeah, it's a pretty good setup. I think in terms of kind of the basics, the bare bones, we've got a graphics set up, ready to do all the kind of graphics work that we'll want for this. Primarily, we don't actually care about that right now. We just need something to be able to visualize what we're doing. And this is basically it. I've also added in this little workflow here, which we can just toggle on and off. That will give us the ability to just throw in kind of our to-do list and keep track of what we actually want to do. Are we doing what we said we'd be doing, or are we kind of losing track, losing focus, and kind of not doing what we intended to do. So as I said, in terms of completed steps, in terms of the kind of the maze work, we've thrown in that ability to kind of generate, or just an example of a binary tree. Now we'll do the same thing for a Sidewinder. And then what we'll want to do is kind of have the ability to choose between maze types. Having the ability to choose between maze types will be that first step for us to start thinking about what is a series of function calls, or like an interface that we can work with, that we can use to generate large series of mazes and kind of rooms that whether they have mazes or don't have mazes, but that connects to other rooms as well. And the idea here is it's kind of like a maze generation API, but maybe the correct wording for this should more be something along the lines of like dungeon generator or level generator. The idea here will be that you can have multiple rooms, and you can give some ideas on what the characteristics need to be for each of those rooms, or just general guidelines, and then you kind of feed that in, and then this program or a bunch of code will take all those features that you've asked for and generate a random scene that still has those features you've asked for, but in a randomized fashion. I think a good example of something like this would be, let's say you have like Diablo, right? The first Diablo, where it's just one massive dungeon going X number of kind of levels down. What we're looking at here is, you can imagine that, right? Like if we just created 100 different levels, and then connected them one level to kind of one level above to one level below, etc., etc., you would be looking at something like that kind of game. Obviously, it wouldn't be a binary tree for each level, there would be variation. There would be like rooms with corridors leading from rooms. Some rooms might have very specific features that the random generator needs to know about and allow for. And then once all those rooms are kind of generated, the specific game can then use, say, okay, what is this room? Let me throw in specific features into that room, because say this room is like the throne room that I wanted. Okay, cool. So, make sure it's got a throne in there, make sure it's got some kind of torches around, columns, whatever it is. But you could add those features in after the fact. This single kind of programming thing that we're going to set up now will do all of that other work for us, just setting up the kind of the basic rooms. And then the individual game can say, okay, cool, now I've got all these rooms, what I can do something cool with them. And so I've already done a little bit of the work for this in a previous project. But the issue with that was it was kind of outside of my quote-unquote game engine. Not really a game engine, I don't know what this thing is. So this is exactly the same engine as what I'm using for the that space game thing that I'm making. And all I did was repurposed it, right? So what we have here is, it's actually got the same starry background, or skybox. But what we have here is just simply the, just a single entity. That single entity has, sorry, not a single entity, that single model type, which is just a box shape. And we've kind of strewn that around here, right? We've got loads of them. They can either make kind of a top wall, a bottom wall, a left wall, or a right wall for a particular grid cell. And then we just say, okay, depending on the maze that I have here, I'm going to kind of have a different series of grid cells. So that's that. I guess we should kind of crack on with some coding now. Hopefully I've explained what we're looking at. And let's get cracking with doing some coding. Righty, let's do this. I'm going to exit out of this and get to the code. And so what we have here is the binary tree code. All it does is it says, okay, so this just kind of says, okay, we can have multiple layers, right? So I could have created 30 layers, and let's do that quickly. So let's run that quickly. And there we go, we've got 30 layers. You can see it runs nice and fast. I mean, this is easy work for OpenGL. So that's all cool, and we can go explore that. I mean, it looks ridiculous, but that's totally fine. But this is 30 different kind of binary trees stacked one on top of the other. Now they don't have any flooring in between them, so they kind of, you can see all the way down the chain, and that kind of looks terrible. But it's pretty clear that there is quite a number of mazes kind of stacked up one on top of each other here. So that's what we could do, and that was obviously really simple to kind of just add in. But what we'll do is just, let's keep it at 2. We don't really care about that though. All that this did was said, okay, depending on your kind of number of rows and number of columns that you want to generate for your maze, which we've randomized per layer, all we're saying here is, cool, let's walk one by one through the grid that we are looking at, and for each cell you do the kind of logic that's required to build a binary tree maze. And so what is that logic? That is, for while you're in each cell, you just say, should I go up or should I go to the right? And that's it. And then there's a couple of edge cases. If you're on the extreme right or top, you have to do slightly different things so you don't break the maze. But like, the logic couldn't be simpler than that, right? Very simple stuff. So this is what that code does, and so that's the kind of the tunneling code, so to speak. And then here's some of that logic around where you create, where you should create walls depending on if you're in those kind of edge cases. kind of literally edge cases in this case, because it's when you're specifically on the edge of the maze that you have to create different types of walls. So what we're going to do now, this is the binary tree, but my thought was, okay, cool, why don't we just do this exact same thing for Sidewinder. And so let's just copy paste that code and come back here and say that we want to create a Sidewinder maze. How do we do that? So what is the logic required for Sidewinder maze? The logic is you need to, well, you start at the bottom left hand side of the maze as an example, and let's use the top of the maze as the kind of the place in which you're kind of working towards. You'll see what I mean by that. What you do for each of these cells is you say, okay, as you step through the cells row by row, you say, okay, I'm going to go through these, and instead of tunneling up or tunneling to the right and then doing the tunnel, exactly like the binary tree, what I'm going to do is say, okay, if I tunnel upwards or in the direction of where this kind of the target kind of empty area is, let's call it that for now. If I say that I choose to go in that direction, then that's a bit of a special case. Instead of it just being simply I'm gonna like travel upwards. So what you do instead is you say, okay, I'm gonna travel to the right, and carry on traveling to the right when I hit that random generator number that makes me go to the right. But when it is to go up, I look at all the places where I did go right before. I stack them up as kind of like a little stack of cells. And I remember that kind of trail that I've made. And then I don't necessarily go up at the end where I hit the kind of the up random generator or generation. But instead, I could now go up in any of the cells I had visited while I was moving right. So say I moved right 4 times and then I had to move up. Instead of moving up immediately, I look at any of those 4 cells and I move up on one of those cells in a random kind of fashion. And then instead of moving up, I then carry on to the right until I finish the row doing the exact same thing. Obviously, when I hit the end of that row, I don't have the option to move to the right anymore, so I have to move up. Again, instead of moving up right there, I see anywhere else that I've been moving right in that kind of most recent stretch of moving right, and then say, okay, for any of those, randomly select one of those and then move up from there. And that's just how you tunnel through your walls on that first row. And then you do the exact same thing on all the other rows until you get to the top. So it's kind of, if we build the logic for that first row, expanding it out to the rest of the rest of the maze is actually relatively straightforward. So let's try do that and see how we get on. Right, so what we're going to say is we are, this is kind of just a place to track where we are in the maze in terms of our building kind of routine. And actually what I'm going to do is I am going to, for now, just comment out the binary tree stuff so that we don't try to generate binary trees anymore, or like draw them or whatever, create the entities for the binary tree. Instead, what we're going to do is generate the walls that would be required for the Sidewinder maze. So we start on the bottom left-hand side of the maze, and we say, okay, cool, let's choose a random number. Are we going to the right, or are we going up? Now, in the binary tree up here, I said, if it's at 0, if you choose a random number, either 0 or 1. That's what this does. If I choose a random number and 0, that's just going to be my tunneling up number, is 0. I just chose that for no other reason than just choose a number. And if it's a 1 that's generated, then we tunnel to the right. So we look and we see, okay, are we going to tunnel to the right, or are we going to tunnel upwards? If we tunnel upwards, that's kind of the special case. So let's tunnel right first, see what we do there, and then generate the walls that we care about, and then we'll think about what else we need to kind of remember for what we will need for when we tunnel up. So thinking about tunneling right, what would we do if this number comes out at a 1? So let's just throw in this code. That's not great. Let's just say if random equals 1, i.e. tunnel right, then we're going to do something, right? So what are we going to do? Well, we know probably that for the cell in question, we're not going to build a right wall. That much we do know, because we're going to tunnel through that wall, right? We're going to destroy that wall. Now, how this code works is that there aren't any walls to start off with. It's not like we start the walls and then we delete walls. Here we don't start with any, so we have to build them all from scratch. And we should build them probably one at a time. As we're going through the maze, we can decide which things to build or not. And that might not be the best way. It might be better to build the walls everywhere and then pick out the pieces that you don't want. Different ways of doing it, but I'm doing it kind of starting from a clean slate and then building up the maze from there. So if you look at the random number is 1, if it is equal to 1, then we're going to tunnel to the right. So actually, coming to think of it, if you tunnel to the right, you don't necessarily build a wall above you, because at some point when we do tunnel upwards, we might come back to this cell that we just looked at and actually decide here we're going to tunnel up, i.e. we're not going to build the wall above us. So kind of if we tunnel to the right, we shouldn't do anything. We shouldn't build anything. So let's not do that. And then let's say, well, if you're tunneling upwards, okay, if we tunnel up, well, then we should definitely, at the place that we decided to tunnel up, we should definitely build a wall on the right-hand side. Because, like, we know for sure that we're not going to be tunneling right at that point. So here we can, and let's just get the code, create wall right. What I'm going to do is, just as a little test, we're actually just going to not have a random number that's equal to a random number. We're going to have the random number equal to an exact number we want. And in this case, it'll be 0, i.e. we're tunneling up. So we should, on our first cell, and actually every single cell, tunnel up. And instead of, let's have exactly 16 rows and columns. And in fact, what I'll do is I'll put in 16, but I'll comment this out so we can get it back another time. And let's run this. So what we should see is, and let's actually make it 1 row and 1 column. What we should just see is 1 wall on where the right hand side of that cell should be. And it's a bit hard to see. We should probably zoom in here. But there we go. We've just got 1 wall by its lonesome. And it looks like there's 2 walls stacked on top of each other, and that's because we started this. So we'll just have 1 layer of mazes for now. And then we can say, okay, cool, actually I want 16 columns. So 16 cells going for each row. And there we go. So for sure, because we're deciding to tunnel up at each stage, we've built 16 kind of walls. But if we kind of remove this and give that variability to how we tunnel, now we'll have a situation where, okay, for a while you tunnel to the right, and then when you decide to tunnel up, you just build that wall. And then here we decided to immediately tunnel up. Here we tunneled right a few times, etc. Here we just tunneled up continuously. So the question is, when you do tunnel up, what happens? What else happens? So the thing is what we do when we tunnel to the right, instead of doing absolutely nothing, what we should be doing is kind of adding kind of a tracking thing. That says, how many times am I moving to the right here? How many times have I been moving to the right? Because when I tunnel up, I have to be able to go back over any of those cells and then decide, actually, I'm going to kind of tunnel up there rather than immediately where I kind of rolled for a tunnel up. So one easy thing I guess we could do here is just have some kind of tracker. Let's put it here. And this, so an I32 is just kind of an integer, normal int kind of value. And so what we're going to say is kind of tunnel right counter, and that will be equal to 0. And when we do tunnel to the right, we'll add 1 onto that. Okay. And then when we tunnel up, we'll immediately create a wall on the right hand side because we know we're not going right. But what we should then do is look at this tunnel right counter and say either at the place where I'm at now or any of those rights, anywhere to the left of me that was where I tunneled right, I have to go randomly select one of those. So what we can do is just create another random, but let's call this random num tunnel rights or something, right? And what that will be, it will be a random number that will be based on this kind of tunnel right counter. Now, just thinking about this, what happens if you immediately tunnel up? What will the tunnel right counter be? It will be 0. And that is a problem because we don't want to mod on 0. We want to mod on 0 plus 1 in that case. And similarly, if you've tunneled right once and then decided to go up, then you should be choosing either kind of between two options, which you would have tunneled right once, and then you want to add on one more to get to 2, and then you'll choose between 2, which that will then be a mod 2 here, which is exactly what choosing between 2 is, mod 2. So you got your random number tunnel rights. Again, if it's a 0, so this will be kind of how many steps to the left should you go to get to the cell where I am going to tunnel up. So that will tell me where I shouldn't build a wall upwards, but I should build a wall at all the other positions. So what I'm going to have to do is create, I guess, a for loop here that will go from let's call them left cell index, something like that. Not the best name, but whatever. Left cell index is smaller than number of tunnel right counter plus 1, right? Because if you haven't tunnel right at all, that would be 0, but you want to be able to do this loop at least once. In that case. And then left cell index plus plus. And if that left cell index is equal to the random number, then don't build above view, otherwise do. So if it's not equal to, then build a wall on top of you, which is this function over here, which I'll just copy paste into here. So I think this is doing what we want it to do. If you tunnel upwards, immediately create a wall on your right hand side, see how many times you had moved right before. For each of those positions, create a wall if that position isn't the place where you want to tunnel upwards. And maybe this should be random number to tunnel up. Maybe a better way to say that. There's kind of random steps left to tunnel up, kind of thing. And it's not exactly that. This left cell index is kind of starting from the left hand side rather than from the right hand side. So that's, or I guess it could be starting from the right hand side. It's left steps. Should we call it left steps? Yeah, left steps is nice. And if left steps isn't equal to the random number of steps to make, then cool. Create a wall on top of you. Yeah, that's exactly logical. Now the issue is where to draw this, or where to create this wall. And so it's not the bottom left of the cell that we are looking at right now, but it's the bottom left of that cell minus the number of steps that you're making. So we need to minus off, and so it's a v3f subtract, and so we'll need to do I guess it will be let's say left movement offset is equal to something. We're gonna, so it's gonna be to the right, so it's gonna be to the left, so that's a negative number. Negative 2 times by the scale of each cell. You're not going to move kind of in a vertical, in a kind of upwards direction, and you're not going to move along the kind of z-axis, which is kind of in and out of the screen, so to speak. We're going to do that not once, but we're going to do that by the number of left steps. We are then going to subtract, or I guess add, because that's a negative that I've got there. We're going to add that onto this to see how far to go, and then that's where we're going to build the wall on top. Now, question is, what happens if we add left steps equal to 0, and that is where we want it to tunnel up? Then this guy should resolve to 0, 0, and we'll build on the cell in question, which is exactly what we want. So this should do something. Alrighty, so it looks like that didn't work. So we'll have to see what's going on here. But this seems to have built, the walls on the right hand side do seem to be working quite nicely. It's the walls underneath, or sorry, the walls on top here and underneath the next row, which are always building. So what's going on with this bad boy will be the question. So if we tunnel up, we create a wall on the right hand side, and then we say random steps to and reflex 3. Yeah, I will be doing some Excel stuff at some point. I have not actually. I've got something of interest there. So it's definitely something that we can look at some point. What I'm very keen on doing right now is getting this kind of maze code, this generation maze API thing. It's been something I wanted to do for a while, and I've already done quite a bit of kind of thinking around it. So I've got a good idea of what we need to do for it, at least as a starting point, and then we'll take it from there. But yeah, Excel stuff. I've got an interesting idea for a game that I think could be quite cool. Haven't done one for like 2 years now, a proper one. So I think it's time. Right, so where were we here? We were, let's see. Probably easiest if we step through this, but let's just crack on. So the tunnel right counter, we do know that we want that. Right, the issue here is that our tunnel right counter, if we go up, our tunnel right counter does need a reset to 0 at some point, right? Pretty sure that's true. Let's see what happens there. Yeah, I think that was the issue. So this looks kind of right. It's looking quite good actually. Yeah, we started here, we decided to tunnel right, then we tunneled right, then we tunneled up. Then what we did is we went back and said, okay, over these 3 cells, where are we going to tunnel up? It randomly chose here and it tunneled up. Then it moved to this cell and did the same process, tunneled up here, tunneled up here. This one would tunneled all the way right and then moved back here and tunneled up. And this one just went up and up immediately. That seems to be working pretty well. We're missing these walls at the kind of the left hand side and the bottom. And actually that will kind of just be, I'm pretty sure, exactly this code. Let's just do a little highlight there and throw that bad boy into here. And that just says if the row index is 0, if you're at the bottom, then always create a bottom wall. And if you're on the extreme left hand side, always create a left hand wall. Quite simple. So let's see if that makes it look a little bit neater. And it does, so that's looking quite nice. So it looks like we've generated the first row. Now the issue is it's hard to see for sure what's happening on the extreme right hand side. When you're on the last cell, you must always tunnel up. There's no option there. You can't tunnel to the right and tunnel outside the maze. So we haven't added in that stipulation. So this should be if random number is equal to 1 and the column index is smaller than the max columns minus 1, right? If you're at max columns minus 1, you have to tunnel up, don't have a choice. So that's just to make sure that we don't have that kind of issue going on. But it looked like our random number generation just happened to be going up there anyway. So it's a bit of a much of a much. Cool, so we're all looking good there. And now we could probably just increase the number of rows. So what happens if we went with 4 rows? And cool, that looks like it's working. So again, just to describe what's happening here, if we do this row first, remember over here we have to tunnel up. We then come back to this row, we start here, and we say, okay, cool, if you're here, tunnel right or up. This one obviously tunneled right, and then it tunneled up. And then on the tunnel up decision of these 2 cells, it chose this one, it went up. Then we moved here, did the same thing, went up here. Did the same thing for these, and then it decided to come back here and tunnel up. So therefore you build the walls above, etc., for that row. Does the same thing again and again and again. And now we can just do it 16 times. And we got a 16 by 16 maze, but there will be an issue. So that's looking great. But the issue is it's right on the top here. You'll notice that we're tunneling out of the maze. That should be closed. So how do we make it such that we build kind of that top wall? So I guess what you could do is when you're on that top row, you don't have a choice what to do. You have to tunnel. You have to tunnel right. You don't have a choice. You don't get options. That leaves that distinctive feature of the Sidewinder, where in the direction that you're moving towards, whatever that final direction is, whether it's north or up, whether it's to the left, bottom, whatever it is. In this case, we're kind of moving everything facing upwards. That's the kind of that kind of random decision when you're across a range of cells and you choose somewhere that's going up. what the Sidewinder requires in order for it to be a maze where each point is able to be reached by any other point, that top row, in this case, has to be completely open in a horizontal way. So that means we have to tunnel right all the time. And then when we get to this cell, we can't tunnel up. We can't do that tunnel up choice, which we said we had to do. So this might get a little bit tricky exactly how to get this code right. But that's literally the last bit of code we need to add in. And then we've got the Sidewinder done. So we are looking good on that front. So let's think about what we're going to do here. And I'll just have a little sip of tea in the meantime. Right. So we know if our random number is 1 and our column index, and we're not on the extreme right hand side, I think what we should say is and our row index is not, whoops, the row index is not max rows. Right. So if we're in that kind of like excluding that ultimate row and column area, then, and you decide to tunnel right, good for you. You can do that. And maybe this guy, that's if you choose right, and it just happens that that's the situation. I think else if your random number, let's see what would happen here if we left this as is. It would decide that at your top row you always tunnel up. That's not what we want. Let's just do it this way. Else if but if your row index is equal to that, right, then always tunnel to the right, except if you're at the extreme right hand side. So if your row index is equal to max rows minus 1, and if your column index is smaller, then if your row index so if you're at that top row, and you're not at the complete right hand side, I'm not really sure we care about that, right? Like, we just build the wall on top in all cases. I guess what we do care is if the column index is equal to the max cols minus 1, then we also want to build a wall on the right hand side to close off the top right hand wall. And then else, i.e. if we're not in that area of concern, then we can just do our normal kind of behavior that we wanted to have. Highly doubt this is going to work, but let's give it a try. That kind of looks correct, except this looks odd. That might be completely by, that might be by coincidence, because we don't have that issue here. But it's always tunneling up on that first one. I just wonder if we've done something a little bit wrong there, but it's probably okay. This one's more a tunnel up, right? I think that's fine. I mean, it looks fine. We can try a larger maze to see if it's still working or if something breaks. Yeah, and that looks better. It's not as kind of strange. So it's hard to tell for sure if this is perfectly valid, but it looks pretty good. I'm gonna assume it is. We can do different types of things later on to kind of verify that. But this kind of looks pretty good to me. Yeah, so in terms of our what we wanted to do was we wanted to create a Sidewinder maze, which we've done. And then we wanted to create a simple example. Yeah, good. And then the ability to choose between maze types. So before I do that, I'm just going to show an example of where we can stack this again, where we can have like different size Sidewinder mazes kind of stacked on top of each other. So we have 4 of them of different sizes, and that looks kind of crazy. But you can see there of different sizes. Doesn't look great though. Why are they all exactly the same height? It's kind of weird. That feels like a too good to be true. Is that fair to say? Max columns, max rows. Why was that exactly? All of them seem to be exactly the same height. I mean, what are the odds of that? This one's lower. Okay, cool. I mean, kind of weird, but that's fine. If we create quite a few more of them, let's create 8 of these guys, and we will create yeah, let's try that. There we go. Okay, cool. That looks a bit better. It's a bit less obviously like things looking exactly the same heights or whatever. Cool, so that is looking good. And we have kind of 8 Sidewinders, and as you can see, that one has kind of every row on the top. Sorry, every cell on the top is blank. And similarly for this one, you can see behind that kind of one behind there, the 2 mazes behind have that same row completely open. So that's looking pretty good. Just trying to think if there's anything else regarding the maze itself that we want to do. I think what we will do now is, again, try to get the wall. What do we want to do? Okay, so now we can say, well, instead of creating a binary tree or a Sidewinder, again, we'll just put in I32. Random maze type is equal to rand mod 2, and that just means that if it's a 0, you could do a switch on this, I guess, whatever, no big deal. Cool, do a binary tree. Let's just say, yeah, binary tree. And if it's equal to 1, which in this case it will always be, else if Sidewinder and now we should have a can see that one has the distinctive binary tree open top and open right hand side, which is kind of just the way that I've oriented the binary tree. You can see that it looks like this one, a bit hard to see what's going on here, but it looks like this one's also a binary tree. It looks open on the right hand side. And finding this one over here, wow, this is difficult to see. That one looks like it's probably a binary tree as well. Although not necessarily actually. Wow, it's hard. We'll need some kind of color scheme going on over here, I'd imagine. But these all look like binary trees, so maybe one at the back is not a binary tree. Although this one also looks like a binary tree, the one kind of sitting behind here. And if we just said that was 1, then surely they would all be Sidewinders. So maybe it's just luck of the draw, yeah. These are definitely not binary trees because you can see they do not have an open right hand side. Theoretically, your Sidewinder could create an open right hand side as well, but I mean, likelihood of that's going to be pretty slim given the size of each of these guys. And let's make that 8. Make them slightly bigger. Maybe it'd be easier to see. So the lighting's getting a bit problematic here, but that's just a closed maze. I mean, all of these look open. But there's a maze sitting behind here that looks like it is. Oh, that's also, I don't know what's going on. Anyway, I'm sure that this is working. I mean, it has to be working, so that's fine. It's just annoying. If we added in a little offset to these mazes, we'll be able to see them in different places and then just be able to tell. So instead of our layer index kind of giving us that, why don't we set that to be 0, and then what we'll do is instead of the layer giving us a Z offset, we'll give it a huge X and Y offset. So maybe what we do is we start off with kind of a V3F XY offset. Pretty terrible name, but that's fine. And that will start off at 0, 0 across the board. XY maze offset. And then it will start off at 0 and you'll use it. So bottom left of cell will equal that, and then plus the maze offset. At the moment the maze offset is always 0, so nothing's happening. But what we can do is at the bottom, and we should be 3F mul F, that guy, by the, I believe, two times that. Might be 1 time, so we'll just have to play around with that. And then we will, instead of it being, so the XY, all we need to do is just add null onto that XY maze offset by exactly the amount of rows and columns. Let's just do one of those. And maybe just one of them. That could be quite cool. So we do a little random choice, and then kind of at the end, after you've drawn your maze, what you can do is you can say that will equal to v3f add that and a new v3f, which will have what's in it exactly, and that will be either the max rows or the max cols. Let's always do the rows for now, Let's always do that for now. And let's just make sure that's a floating point number. Once we've done that, I think that will just do a nice little running total. Hopefully that works, because we do multiply by the scale, which is up here. And so I've added them. Yeah, did I do rows? And then, yeah, sorry, I did rows and then kind of going vertically, right? So cool. So basically it's just whatever the number of rows were for this guy, start the next maze exactly above that. And then so you can see there's a maze here, then there's a maze, this is another maze. And that's the nice thing about the fact that we got like these borders, is that you can see exactly. But why don't we just do it max, like rows plus 1.0 or plus 1, max rows plus 1. And we can just see that then. So a little bit of a gap between each maze, we can kind of see them. It starts to get hard to see them up here because the lighting is quite dim. I think I can add on some intensity into the light, which we can do down here. So the light color, maybe we just make that 1,000 and 1,000. It's going to kind of drown out some of the maze color wise, but that's fine. And so yeah, as you can see, this guy looks like a binary tree. 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 This guy. What is going on here? Why are they all coming out of binary trees? I must be doing something a bit silly. And it's hard to see these guys again. Let's just reduce the number of rows that there can be, just to make it easier to see the entire series of mazes. And why do we have these guys stacking again? We don't have a Z. So I'm a little confused as to why we have Z. That's problematic. Bottom left a cell thing. That's the problem with having duplicate code. You change it in one place and you forget to change it in another. Right, so there, binary tree, and he has a Sidewinder, because we have some things there. Sidewinder and Sidewinder. Binary tree probably might be a Sidewinder. That looks like a binary tree. That's a Sidewinder. And you can see like the shape of a binary tree. It looks like it's quite diagonal. So that's like probably definitely a binary tree. It's looking quite diagonal. Same as this one, possibly. Like you can never kind of go left in a binary tree, kind of. So that's kind of looking Sidewinder-y just by the just kind of glancing at it. This looks like a binary tree. It looks like it's kind of doing that kind of diagonal movements. This one's a little bit harder to tell, but probably a binary tree. And yeah, cool. Well, that's good. I think what we should do is either move up or move to the right. How about we do that? So little random number again. Move direction is equal to that. And then if the move dir is equal to 0, let's call that also move up, because we had 0 as tunnel up. These will all be like codified at some point. So let's not get too worried about that. But then we'll just do exactly what we're doing. But if it's not, then we'll the maze offset will actually be a row, not a column. Sorry, other way around. It will be a column, not a row. and it will be in the X area, not the Y area. It'll be cols, not rows. And now we should have something a little bit more interesting. Here we probably started here, went there, then here, then here, then here, then here, then here, then here. Cool. And that's looking quite nice now. We've got a little bit of a series of different rooms with different mazes in them. You could imagine like them being connected, possibly in one or more areas. You could go through different mazes to get to other mazes. There might be some corridors that link up more disparate mazes, and then you don't necessarily have to have a gap of just one between these mazes. You could have a very much larger distances, and then like long corridors that kind of connect them up. That's kind of looking quite cool. I think we should probably leave it there now. I think we did all of what we said we were going to do today. Maybe we could just create a few more rooms just to see this thing work. But then I think we're going to call it a day. So let's do that quickly. So layer index, this is kind of a misnomer. It's more like number of maze rooms. So let's call it like maze room index. And that's not actually used anywhere, which is fine. It's just a counter. Let's have 60 mazes. Boom. Cool. So there we go. We're generating them because we always move to the top or to the right. And then here they're kind of just going, there's not enough lighting to see what's going on over there, so who cares. But down here, we can make these a lot smaller just so we can see like huge numbers of mazes. So why don't we make this like 2 and 2. So these are going to be pretty small mazes. And there's just like loads of them. So there we go. And they go all the way up here. We could zoom out, try to get a feel for all of these. And again, you could link all of these up. And then, so there we go. Got a whole chain of these kinds of mazes. And these are very small ones, but you could imagine much bigger ones as we had before, even like ginormous ones. What happens if we made this go back to 8 and then this number to 10? Right. So here you've... Alright, we've got a bit of a problemo. We're probably running out of some kind of space with our maximum number of entities that we can have in the game. So let's not do that. That was mistakes were made. Let's maybe not try create that many walls. So there we go. Cool. And that's just going to be absolutely massive. And is, one of the problems with this whole thing is that we're generating walls, which are entities, which you probably would never want to do because now you just have a huge number of entities. Maybe that's a terrible idea. Maybe it's fine, because if you segment your game in a way that makes sense, then that would be okay. Anyway, the API won't enforce you to create entities per wall. That can be your kind of decision. What it will give you is just kind of a data structure that tells you where to create those entities if you wanted to. It won't go and pre-generate those entities, which could be big data structures that you don't want to kind of fill up your memory with. That would be the idea. But you could just have Boolean flags, right? Like, is there a wall up? Yes or no? Cool. At particular grid points. Something like that. That's the idea. Not sure exactly what that's going to look like, but it will hopefully look like something quite interesting. Anywho, yeah, that's it for today, guys. I will be posting this one up on YouTube, and hopefully we will be back in the next few days, maybe tomorrow, maybe slightly later than that, to see what to do next. And what I think we'll do next is add in a couple more maze types. So the recursive backtracker and the hunt and kill algorithms, we can add those guys in. And then we can add in the ability to choose those rooms and to kind of have rooms within rooms and all kinds of crazy stuff. That's probably what we're going to do, at least some of that for the next session, and then start building this idea of what is it that we want to allow for the user to ask from the API, and then the API takes or creates something and gives it back to the user, to the programmer. That's what we want to try and work out. That's the main thing. So we want to start thinking about that probably. But yeah, until then, I'll see you guys around. Cheers.